All right, you guys. So I've already made a little table for number 23 to help us understand it a little bit better. So back to the very first thing we did this year, which was recursion. And I made a table based off of if u sub 0 equals 2, then my 0 value is 2. And then what's happening here is I'm multiplying for each new value, okay? For each new value, which is u sub n, I'm taking 3 and I'm multiplying it by the previous value. Okay, so if my first value 0 is 2, then my first, in air quotes, value would be that number times 3. So 2 times 3 is 6, and 6 times 3 is 18, and 18 times 3 is 54, if my mental math is correct. So we're just trying to match this up with one of these equations over here. So if I make x 0, what will this be? Well, anything 3 to the 0 power would be 1, and 1 times 2 would be 2. So if I put in 0, my output is 2 back, right? Cool. So it works for the first one. Let's check for the second one. 3 to the first power is 3. 3 times 2 is 6. So works for the second one. If I put in 2, 3 squared is 9. 9 times 2 is 18. Works for the third one. And you will be able to see it does work for the next one. So we lucked out. The answer is A. Okay. The answer is A. If you want to pick it apart in an exponential relationship, this 2 here, that's our starting value, which was our starting value here. And then this number is the number that we are multiplying by each time. Now, would it have been the same if instead of u sub 0 equals 2, we had u sub 1 equals 2? If that was the case, then our table would have changed. Instead of 0 being 2, it would have been 1 being 2, blah, 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 blah. And we would have had to have gone with C as our answer, okay? So I hope you realize the difference between A and C. And I hope you realize we could have canceled out B and D because the starting value and the growth factor were reversed, okay? All right, question number 24. The population of a U.S. state in 1990 was 4 million and the population in 2010 was 6 million using this equation. And so we're so lucky when questions give us equations. If there's an equation, we can solve it. Where P represents the population of millions, T represents the time in years, R is the growth rate, blah, blah, blah. What are we trying to find? P sub 0 is the initial population. Determine the growth rate that represents the change in population between 1990 and 2010. Okay, so we're still lucky. We want to find the rate. So we're trying to find R. So hopefully in this equation, we will have a number for everything except for R, which will make it pretty easy to solve. So in this equation, P, well, let's start with P sub 0. P sub 0 is our initial population. So, and I know if we're only looking from 1990 to 2010, our initial population is going to be the population from 1990. So that was 4 million. And we'll just use 4 and we'll assume millions as we do this problem. So our initial population was 4, okay, times 1 plus R is what we're trying to find. So that's going to stay a variable. And then I have 2 more variables that I need to put numbers in for, okay? And that is a year. I need to have a year here, okay? And I need to have an output for a population. So the question is, did this question give me, besides the starting year, an additional year and a matching population? And it did. It gave me 2010. And the population was 6 million. So 6 million is going to go here. And 2010, I'm not going to put 2010 up here. I'm going to put the number of years 2010 was since 1990. So the number I'm going to put there is actually going to be 20, right? So now that I have every number except for the number I'm trying to solve for, it makes this super easy, you guys. You just work everything backwards. So first step, divide both sides by 4. So you get 6 divided by 4, this whole thing divided by 4. Here your 4's cancel, And you have 6 over 4, which is 1.5, if I'm doing my mental math correct. So I'm sorry, it's going to get messy because I didn't leave myself much room. Where can I go? Where can I go? So 1.5 is equal to, in parentheses, 1 plus r to the 20th power. Since 1 plus r in parentheses, the next thing I have to get rid of is the 20th power. So if you remember this year, the way we did that is we took this whole thing to the power of 1 over 20, which canceled out the powers, right? And you got to do that to both sides. Now, you could also, 1 to the power of 20. You could also take the 20th root. Either way, it will give you the same answer. So let me put my calculator. If I take 1.5 to the power of, oh, that was weird. Delete, delete, delete. Delete. 5. 1.5 to the power of 1 divided by 20. Very important. Enter. I get 1.02048. I'm going to use all of those numbers. Okay, or you'll see why. 1.0, oops. Oh yeah, 1.02. 1.02, what was it? 048. 048 is equal to 1 plus r. So only one more step to get r by itself, and that's to subtract 1 from each side. And I hope you realize when I subtract 1, we're just going to get this decimal, which is 0.02048 equals r. And that makes a lot of sense, actually, because r is actually a percent, right? So there's the decimal. If this was a percent, I multiply 100, it would be 2.05 if I round percent. That is the growth rate that represents the change in population between 1990 and 2010. Okay. And then up here, right, actually would have been the growth factor. That's the difference between the growth rate and the growth factor. 25, Ricardo invests $500 at 6% interest, compounded annually. That's important. Compounded annually means I don't have to divide by 12 or whatever to make that weird equation. Also, what's cool is you can figure that out by going back to that other question that we had before, right? The value A of an investment can be calculated by using this equation. Again, so nice of them to give us an equation where P is the initial investment, R is the interest rate, and T is the time in years. Approximately how long will it take for his investment to be worth $2,000? So $2,000 is our outcome. We want that to be equal to approximately how long? Oh, so I'm going to be solving for T, which is in the exponent, which means I'm going to have to do a log at some point here. But what was our initial investment? $500? 500, that's P, times 1 plus R. R is the interest rate, and that is 6%. So 1 plus 0.06 is going to be 1.06 to the power of T. Okay, so divide both sides by 500 to get rid of that 500, and that's going to be 4, I think. So 4 is equal to 1.06 to the power of T. It's really messy, guys, sorry. So now I have to do the log. I need to do the log of 4 and the log of 1.06 to the power of T. And what that looks like when I'm done is just the log of 4 equals T comes down, T times the log of 1.06. Then we just divide both sides by the log of 1.06. So the log of 4 divided by the log of 1.06. We'll just put this here because I can't write it again. Dividing everything by the log of 1.06. On the right-hand side, it cancels. I just get T is equal to log of 4 divided by the log of 1.06. I need my calculator. The log of 4 divided by the log of 1.06. 6. Oh, I did it. Okay, just remember everything after your log and these old ones has to be in parentheses. Enter 23.79. So 2 is approximately 23.79. Does that answer our question? What am I looking for? Approximately how long will it take? It would take approximately 24 years. It looks like that's a long time. So just having that same amount of money sitting in there, if you're not adding money each time, it's going to take a while. So add money to your accounts, guys. Okay, what's next? 26. Is that the last one? Jeez, how many problems did I give you? So 26. Do I have time to start? Yeah, I'll start this. Why not? Okay, so it's recursive problem, right? Suppose your aunt started a new dosage of 50 milligrams of allergy medicine and takes it every day at the same time. Her body eliminates 40% of the medicine each day. Create a mathematical model for this scenario and determine the amount of body in her blood after 5 days. So this really is best used as a recursion. So our starting amount, if I use u sub 0, where n is greater than or equal to 1, and we start off with 50 milligrams. So after she takes her first pill, right? Otherwise it'd be 0 and it would be weird. And then what's happening each time, to get a new day, we have to take the day before, so subtract 1 from that, and multiply that by 0.6, because 40% is going away and 0.6 is staying. And then what's happening is we are adding 50 more milligrams a day, so plus 50. Okay, so that would be your equation. And if you wanted to figure out how much she had on the 5th day, that's what it's asking for? After 5 doses. So after 5 doses. So after the first dose, which we said was actually 0, after that first dose she had 50. Then after one more, you multiply 50 times 0.6. And you get 30, but then remember we have to add 50 more, so you actually get 80. I'm doing this fast, you guys. I hope you're checking my math. So then 80 times 0.6, enter, and then we're adding 50 more. So then that next day we have 98, or the next dose. It's saying doses. 98. Okay, I'm going to pause it and do it so we're not wasting tape. All right, you guys, so after a couple more times, we figured out that after her 5th dose, she would be at 115.28. And even though it's the 4th input, since we started at 0, that's actually the 5th dose. 1, 2, 3, 4, 5. So just be careful at that. You can start with 1, 2. That might be less confusing for you. Anyway, part B says the doctor needs her to have 150 milligrams of her medication in the bloodstream each day. So that makes it really simple. That means today she needs to have 150 milligrams. And that means yesterday she needed to have 150 milligrams. 0.6 is still staying in her blood system, but the question mark is, how much does she need to add to herself each day in order to make yesterday 150 and today 150? So 150 equals 0.6 times 150, which is 90, plus our x value. To get x by itself, we just subtract 90 from both sides, and we get, I think, 60. X equals 60. And what does that stand for? That stands for the milligrams that she needs to take every day in order to keep 150 milligrams of medication in her bloodstream each day. Boom.